single fiber theory. Then role of fiber assembly. Whenever it goes into the fabric, then the role of fabric assembly becomes very important. And particularly the role of single fiber theory becoming less relevant in the case of liquid filtration, because the viscosity is so high. Okay, particle size will be also generally high, except in a very few cases. Okay, so because of the higher viscosity and because of higher density, penetration of the particle through the filter media will be higher. So as I am showing you this media is used for air filtration application for pre-filter. Okay, for example, HVAC filter, for this room we need the clean air. So for the clean air we can have the HEPA filter. Okay, HEPA filter one, but because before the HEPA filter we can have pre-filter. Okay, before the HEPA filter we can have a pre-filter. So role of pre-filter is to arrest the larger particulate matter, but it will allow the finer particulate matter through it. Okay, because it cannot arrest the smaller particulate matter because it is quite open in construction. Okay, so it is termed as pre-filter. Here another media I am showing. This is for a liquid filter media. If you see, this is the oven fabric. Okay, the front side is different, back side is different. That also I will discuss in due course of time. So here this is the cake side. Okay, this is the back side. Why I am referring to the cake side? Because the disposing of cake must be good. Okay, that is one of the property which is required. I mean, in subsequent lecture we will see how is it important to dispose of the cake. Now tell me whether the cake should be disposed of to the landfill area or what to do with the cake. Whether the cake is really important for us or it should be always disposed of. Yes, depend upon the requirement, because if you are going for mineral application, if you get the mineral should not be disposed. So for mineral application, that is the useful matter that you can make use of. Okay, so but suppose if you are going for wastewater treatment, so whenever you are getting the cake, that can be disposed of, because in Amritsar and several places you can find that zero waste, water discharge. What is that terminology? Zero liquid discharge. So basic idea here is that the same water is recirculated in the process. Sometime it may come through reverse osmosis, sometime it is maybe from the ultrafiltration, but again we are using this. But suppose if you are going for white goods, it is always advisable to go for RO, reverse osmosis, whenever you are making use of that water. So you will get the dry cake. Liquid, see, liquid can be reused in the process. What? Media. Yes, yes. Media, it is not that it is for one time use. Okay, so it can be used repeatedly because it is a continuous process. Okay, again if you are going for the RO filtration, it is a continuous process, it will happen, but time to time you will have to go for backwash. Okay, so that is necessary for membrane filtration. In all membrane filtration, time to time. Yes, yes, regeneration is required. Okay, because membrane is very costly, so you cannot throw it out. So time to time you will have to go for regeneration. Okay. Okay. If you see further to that, if you talk about the surface filtration, depth filtration, whenever I talk about this kind of filter, it will be at certain depth the particle will be arrested. So this is known as depth filtration. Surface filtration means it should be on the surface. Why you are not going to the depth? Because the depth filtration will lead to the higher pressure differential. Okay. Yes. Okay, because this side is more smooth. Okay, because of the smoothness, it can dispose of the cake, because that is why it is engineered. This material is engineered in a particular way. That also I have shown you that this side will be rough. Okay, but this side is very smooth. Okay, because this can be done by means of weaving. I will tell you in due course of time. I will tell you this side has to be smooth so that you can dispose of the cake properly. Suppose if you are going for span yarn, I don't know how many of you know the span yarn, hairy yarn. So span yarn will be on the back side. Because of its hairiness, its filtration capability will be more. More and more you can have the filament on the front side. Front side, because of the filament, it can dispose of the cake in much better way. If you see the structure of denim, because one of the candidate wearing denim, see back side is different, front side is different. Okay, how it is possible? So it is possible by means of weave structure. Okay, so that way we make the weave structure such that this side is smooth, so can then dispose of the cake properly, and back side is rough. Okay, that will give you the more filtration capability. Now, one of the interesting challenge, there are many challenges. So dispose of cake is one sort of challenge, but there are many challenges. Suppose if you make this structure very compact, okay, then what will happen? Pressure drop means the pressure drop directly linked with the energy requirement. For the industrial perspective, energy requirement plays a vital role. Unnecessarily, if you are using a filter media which is very compact, then obviously energy requirement will be more. Okay, but the filtration capability will be high. So we need to have the balance between the filtration efficiency and also the energy requirement, energy balance. So pressure differential in filtration, remember the three aspect is more vital. Wherever you go, it may be air filtration, it may be face mask or whatever. Okay, wherever you go, three aspects are very, very important. One is the efficiency, second is the pressure drop, and another one is the life of the filter. These three things. Life of the filter. Efficiency, definitely, efficiency. Because sometimes it can so happen that smaller particle efficiency will be lower. So that's why there also we talk about the fractional efficiency. Larger particle efficiency will be more. So efficiency is not that it will be equally applicable to all sort of particle size. So therefore in the research study, one must go for fractional efficiency to see what is the efficiency at different level of particle size. Because if you are giving a broad picture, gross picture, that may not tell you that its performance is good, because that all depends on the particle size, because larger particle size efficiency will be good. Another restriction is about the sensor. Certain sensor cost will be shooting up if you are going for very high sensitive sensor. For example, if you are going for SMPS, okay, scanning mobility, another is the dynamic light scattering, which is used for liquid filtration. Okay, so it is starting point is important. Starting point, what is the micron value of the starting point, that is important. If you want to register or if you want to measure the particle size at a very small sizes, the cost of the equipment go into in a 80 lakhs, 1 crore. Okay, normally the sensor might cost you 20 lakhs. Okay, but it can go up to more than 1 crore if you want to find out the particles which are below certain value. Okay, so sensor cost is very, very important whenever. So it is not that it is giving you at a particular size of the particle, if you are getting efficiency, it is all fine. Not like that. It all depends on the application. Suppose the application demand that very fine particulate to be removed, so we must see what is the efficiency at that particular level, and for that the sensor requirement will be different. So different application, that's why I need different kind of setup. It is not that in a single setup we can do everything. It is not possible, because everything should be aligned. Okay, sensor should be aligned, everything should be aligned. Now if you see here, I am showing you surface filter and another one is depth filter. In depth filter, the retention, if you see, it could be 60 to 90%, okay, for a particular size. Okay, in surface filtration you can have the retention like this. So a particular size, if you say the retention is 90% for this particular particles, I think there is some problem. Is it okay? So we can get 99% efficiency for that particular size. Okay, so that is possible because it is an absolute filter. Okay, because the pore size is very uniform, but whereas the pore size is not very uniform, okay, and because you can have the small pores as well as large pores, so you cannot maintain the one particular efficiency level for a particular size. That is not possible. But if you are going for a woven fabric, you can maintain a particular efficiency level, okay, high efficiency level, okay, particular efficiency level, and that could be constant. You can maintain it at a constant level. Now, if you see, the concept of complete blocking filtration and bridging filtration is important. Because if you talk about the air filtration and cake filtration, mostly if you will find this thing is very prominent. I am not talking about the ultrafiltration, RO and all this, because there this matter. The pore size in the membrane matters, because in the liquid you are having few particles. Okay, particles load will be much lower if you are talking about the reverse osmosis, ultrafiltration. Okay, as the particle load is very less, so therefore the blocking mechanism basically work. But whenever the particle load is more, in that case quick cake formation will happen and the cake will take part in filtration process. It is not after the cake is being formed, the cake act as a filter, not the fabric. Fabric role becomes secondary. So it basically initiates the cake formation. Once the cake formation is over, then it takes part in filtration. If the point is clear. Okay, so but it also happen in the case of industrial filtration. Okay, in many cases, people basically if they don't attend a proper class or they don't read through the literature, they will always think pore size is larger, so particle will pass through. It's not like that. This is not the philosophy. Basic philosophy, it can that we can have the breach filtration. Okay, and breach filtration, it is possible to capture even the small particle. Yes, when the cake, because cake will form in a very quick span of time. Okay, sometime what happened, the people going for pre-coating. Pre-coating means you go for cake formation, okay, by using some, that I will also tell you what material to be used. So cellulosic component can be used for pre-coating. Once you are going for pre-coating in some of the application, so better cake formation will be there, disposing of cake will be better. So pre-coating is also essential in certain application. Now if you see the depth straining mechanism, depth retaining mechanism, at certain depth it is retained, okay, but in certain depth it is straining, because we are thinking, we are conceiving the pores like this, but actually the pores in the non-ovens is interconnected in nature. But researcher, what they used to do, they conceive the pores like this way, zigzag manner and all this. But actually non-oven pores are not zigzag manner, but the point here is that they are all interconnected pores. Particle can maybe passing through from the top surface, but it can get caught at certain level. So depth straining is very common, but the depth retaining in the case of liquid filtration is uncommon. In air filtration it is common, depth retention. It is very common in the case of, like if you are using the pre-filter, depth retention is common in the case of air filtration. That is why air or liquid, in whichever is the case, flow velocity basically very important. If you are having dominant flow velocity, then obviously the retention at certain depth may not be possible. That is why the flow regulation is very important. Okay, it is not that suppose if you are going for any designing of the filter media or filter HVAC filter or whatever, why you are going for first of all pleating? What is the reason for pleating? So we can get larger surface area that can be accommodated in a smaller space. Even in the automotive also, we go for pleating so that we cannot accommodate larger surface area. Pleating. What is the basic purpose of pleating? Basic purpose of pleating is the reduction of the velocity. If you can reduce the velocity, that always helps in capturing of the particles. That is the basic philosophy. That is why the people going for pleating. Okay, again in the oil filter and everywhere, space is one aspect, but it is better to say that by giving you the more space, the volume flow divided by the area, that is filtration velocity. Volume flow will be meter cube per minute divided by area meter square. So if you do that, so from that you will get the velocity. So velocity should be as small as possible, whichever is the application. Okay. But if you are having the nearly zero velocity, that will be perfect. But the problem is that there will be huge requirement of the filter bags, or in this case a larger surface area is required. That's why it also is a balance. You have to make a balance. What should be the sizes that you can accommodate? Because if you can reduce down the velocity to the zero level, obviously you can have more and more capture, but we cannot go for zero level, as because the size of the filter will be huge and that will be difficult to manage. Now this is the tortuosity factor. So that can, again it is conceptual, that machine whosoever measure the fabric properties, they can provide you the tortuosity factor, and this is how the tortuosity is defined: length of the pore path divided by the thickness of the material. Greater the tortuosity, greater will be the capture of the particles. If you see, sometimes it is also being said that if you are making the non-woven needle punch, if you are going for angular needling, so in the case of angular needling, the path of the pores will not be straight. Okay, if the path of the pores is not straight, that will be better for filtration application. So different types of structure is there, and non-woven, one of the problem here is that you can, if you are having straight path after punching process, you must have certain, to certain extent I will discuss the non-woven fabric also, manufacturing also. Okay, so if you are having straight path, so in that case the particle can penetrate through. So if you see, another aspect, important aspect is the cake filtration. Okay. Okay, so point here is that in majorly air filtration application, non-woven is preferred. Non-woven is preferred, like this material is preferred. Okay, in majorly air filtration application. Okay, majorly. Whereas in the case of liquid filtration application, people prefer woven fabrics. But again, there is a but. People are moving towards development of non-woven, because last class also I have shown you that very compact kind of non-woven can be used, which can assist for surface filtration. So that non-woven can be specially made. What is the advantage of non-woven over woven fabric? Anyone? No. Cost, obviously non-woven cost will be lower. But what is the advantage? Basic advantage of non-woven?
Smaller particle capturing as compared to their pore size. The pore size distribution.
Okay, any other point, right? This is.
There is no uniform pore size.
No, that is what, but uniform pore size is not a very good point. As he said, that point is correct, because each and every fiber take part in filtration. Each and every fiber here. But here the filaments are consolidated. Okay, then you make the yarn, then you make the fabrics. Okay, so here individual fiber take part in filtration. So obviously filtration capability will be more, but there is one major point you are missing. What is that? Yes? Width, you can consolidate it. I mean, you can make it compact. One of the, as I told you, that there are three aspects: life, okay, pressure and filtration. Pressure differential, because in non-woven you can make more voids as compared to, for similar retention, non-woven can give you more voids. More voids means what? More voids means less pressure. Okay, but one of the problem with non-woven is that life, as compared to woven fabric, the life will be less. So you will have to make again balance between the life and the pressure drop, because here the depth filtration will be there. If the depth filtration is there, okay, you intend to go for surface filtration, but you are going for depth filtration. So what will happen? Life will be reduced. Okay, so because of less pressure drop across the filter media, you will get better energy saving. Energy saving will be better. Okay, for the same capability of efficiency, that is the advantage. But one of the negative aspect of non-woven is the life will be relatively less. Is the yes, pressure drop, that is the plus point. Otherwise, the woven fabrics should have been totally replaced by non-woven. Another point is there in the case of non-woven, the dimensional stability in the case of woven fabric will be better as compared to non-woven, because if you see the process, the material will be under constant stress. Stress level to the material, unlike the air filtration process, liquid filtration application stress level will be very high. Okay, under the stress level it will not deform, but if you apply certain stress level, here the material will be deformed. Okay, if it is not compactly packed. So that is again another problem. Okay, as the life is concerned. So as I am saying, the three aspects can define which material can be used, should be used. One is the filtration efficiency, okay, fractional filtration efficiency, better to say. Second is the pressure, and third is the life. In three are very important whenever you are selecting the filter. Now in the cake filtration, if you see, as I told you that once the cake is formed, the roll of cake becoming very important, because the fabric roll becoming secondary. But most of the cases we forget, we assume that particles as spherical body. Okay, that is our assumption. That is again a problem. Okay, basic problem in most of the research is that we take the data and never think that what kind of data we are getting. That is the problem. We can have different kinds of the dot particle. Okay, it can be flake-like. Okay, but its equivalent spherical size will be much lower. It could be needle-like. Equivalent spherical size will be much lower. Okay, so if you talk about the needle-like particle, capturing will be more in the case of needle-like particles. And whether there is a hydrophobic or hydrophilic particles are there, that also influence the cake formation, the nature of cake formation. So it is not that you can see the data from the instrument, that is okay, but you will have to see that what kind of particulate matter is. Is it is a differently shaped or it is a nearly spherical, but particles are never in spherical shape. So again question arises that why we take the spherical in shape? What is the reason? Why not other structure or other type of dimensions? Why we take it as spherical shape? Any answer? Why we take the particles as equivalent spherical body? What is the basic reason? Why sphere? Why not in other shapes?
Whichever direction it moves, it will have the same. Calculation wise, it is easy to calculate.
Because sphere is only material where you can indicate the dimension by diameter. But if you take any other shape, you can have multiple dimension to indicate the size and the shape of the material. So sphere is the unique in that sense, because by diameter, indicating the diameter, we can indicate the size of the material. That is why we use sphere as equivalent body. Okay. Now if you see in the cake filtration, little bit I have written about the cake filtration. Cake compressibility is very important. Okay, the ability to cake to compress under pressure affect the filtration rate and cake properties, because cake property will be changing under cake compression. Okay, so is it a compressible cake or not? That also matters a lot.
But the cake formation is we will not be able to control, right?
So it all depends on the type of the solid particle you want to arrest, because solid particle sometimes could be compressible, it could be non-compressible. Okay, so depending on the type of solid particle, compressibility will be there. Filter rate, this is again a very important concept.
With the time that the cake becomes thicker and thicker and it
Yes, that's why you need to dispose of. Like yesterday I had shown you, in a damp filter it is gathering, then the cake is disposed of on the other side, because suction is effective in a particular zone and some zone it is not effective. That's why the disposing of is possible.
But if we have a tubular kind of a filter, then disposable.
No, that's why in a tubular kind of filter means, if you talk about the ultrafiltration, their contaminant level is very, very low. Okay, we cannot go for immediately that application. See, if you go to the okay, we are just talking about the what you can say, the wastewater treatment. Wastewater treatment, our several places, after several stages, after we remove the large particulate matter, debris and everything, then finally we go for that particular application. You cannot use that application immediately. Are you getting my point? You cannot use the ultrafiltration immediately having the large quantity of the solid. You cannot, because that is also referred in one in the PPT also. What should be the recommended value of the solid content so that you can go for ultrafiltration, RO. If you are having higher solid content, there is no point of going for RO immediately, because it will damage. That's why whenever we talk about the depth filtration, okay, or blocking filtration, we will have to see the context. Okay, for example, in automotive clean air, although I am referring to air filtration time to time, for clean air, after its life is over, we throw it out. Okay, but it will take at least 6 months to saturate. But in Indian road condition, it may be 2-3 months, but it will take at least 6 months to saturate. Why I should have cleaning? Here, cleaning mechanism is not required. Only the exception is the water tank. If you see, the water tank moves over the dusty land, lot of dust is emitted. So the people going for cleaning also, intermittently cleaning, because they don't have to change the filter. Intermittent cleaning is there. So In certain cases we go for intermittent cleaning also, but normally in all automotive it is under depth filtration. So depth filtration is workable only when the dust concentration, particle concentration is very less. Okay, we can have reasonable time period after which you can throw it away. That is as simple as possible. But surface filtration will have to go for cyclic process to regenerate it, like we are saying regeneration. So cake filtration is widely used in various industries: wastewater treatment, food processing, chemical processing, mining. Okay, now you can see this is the kind of pre-coat material. Okay, D, very light cellulosic matter, just now I mentioned. Another material that can be used as a filter aid, especially in the situation where silica cannot be tolerated. So here if you see, this is the layer, this is the dust cake. Okay, I will show you the application. So this is the pre-coat layer, inside it you are having the main material. So initially you must pass the pre-coat layer, okay, you must pass the liquid having the cellulosic matter, for example, to make a pre-coat on the fabric surface, okay, to pre-coat on the fabric surface, so that you can arrest more finer particulate matter. Okay, I will show you what is the advantage. So to protect it from blinding, so pre-coating can give you the advantage of blinding. Okay, to protect it from blinding, so life will be more, to assist in the collection of particularly fine particles, to enable more efficient cake release. So these three things is possible. Coating means that in the liquid bath you can have cellulosic matter, for example. You can initially you can expose it with this liquid. Okay, once it is getting exposed, so obviously fabric layer we can have some pre-coat. Then we can run the main material through it. Okay, main I mean liquid and solid through the assembly. Okay, so it will act as a pre-coat. If you see here, if you see outside it is a pre-coat, inside it is a cake. Okay, so it can give you the great advantage in certain application. Okay, suppose in silica is not required, cannot be tolerated, so obviously you need the efficiency at much higher level, so you can go for pre-coat.
This pre-coat has to be porous in nature.
Yes, yes, obviously it has to be passed through pre-coat and also, but pre-coat can give you more filtration capability. Okay, and it can be also disposed of in a much better way. Okay, because normal cake filtration may not be disposed of. Okay, but pre-coat can be disposed of in a much better way. Now another classification is dead end filtration and cross flow filtration. Now in a dead end filtration, as I told you, that it is the flow will be perpendicular to the plane of the fabric. Okay, cross plane, like ultrafiltration, RO, everywhere you will find it will flow in the plane of the fabric. So ceramic, metal, polymeric membrane, all type of membrane is possible. It can be made out of ceramic, it could be made out of metal and polymeric membrane. Manufacturing of membrane is also very great task. How to improve the membrane? Suppose if you make the membrane thick, okay, then pressure differential will be more. Okay, how to make a membrane fine, okay, and longer life? That is again a challenge for various applications. It is not this application. Wherever you go, for example, for high altitude, if you want to use the membrane inner side of the fabric as a breathable layer, so there also it is important how to make the membrane very fine at the same point of time to make the membrane strong. Why it is required to be made very fine? So that the pressure differential can be addressed. It should be less. Okay, that is one of the tasks for the membrane manufacturer. I have seen in one of the international conference, the people are keeping the membrane and above it there is a water body. From the bottom they are flowing the air. So in the liquid you can see the bubble of air, because air is moving from here. This membrane is arresting the water body to fall off, but the bubble will be moving up, but water is not moving down, because the membrane size could be, size of the pores of the membrane could be 0.0001. Okay, it could be so small. Membrane size should be so small, it can allow the vapor, okay, but it may not allow the water. Okay, so membrane manufacturer, again that depends on the place to place, the membrane will be different. Now if you see here, flow direction, it will be parallel, So here proper cake formation will never take place because it will be shearing all the time, it will be shearing out, but then how it is getting managed, so that also I will tell you. And dead end filtration is most common. Okay, dead end filtration, this is the dead end filtration where it is perpendicular to the plane and here it is parallel to the plane. Now you can see the dead end filtration, blocking filtration. Okay, this is the testing, water testing and biotherapy manufacturing. So basically the contaminant low, as I said, it is very less. So we are going for blocking filtration in the case of dead end filtration. Contaminant contaminant level are very low. Now this is interesting to see. Okay, now the working principle of the tangential flow filtration. If you see, this is the cylindrical body we have talked about. Okay, and this is the particles which are moving through the cylindrical body inside. There could be also outside to inside filtration. Here I am showing you the inside to outside filtration. Okay, so this particles are moving through the cylindrical body. Okay, now it cannot, see, in this case the filtration is not possible because there should be restriction. If you see in the second picture, we are imposing certain restriction for the fluid flow. Otherwise, the filtration is not possible at all. As because you are putting a restriction, you are making the other side tight. What will happen? Because of this, you can have permeate flow. Permeate flow means the clean water will move through the membrane. This is the permeate flow. And retentate flow. Retentate flow means which is having some residual, which is having the solid particle. Okay, this again will be circulated in the process. So it is not a single setup. So there could be multiple setup. Once the retentant is passing through, it will move into the another unit. Okay, another unit, then gradually the water will get filtered out. Okay, and you are getting the solid content. Okay, in the retentant. Okay, so if you see, here is a particle, restriction is there, restriction must be imposed. Permeate flow, this is the permeate. So suppose here it is passing through the membrane from the top and from the bottom, although it is cylindrical. Okay, so from all over you will get the permeate flow. Okay, and this is the retentate flow. Retentate flow means which is having the particles in it. Obviously the quantity of water will get reduced. Getting my point? Quantity of water will get reduced. Huh? RO, yes, RO ultrafiltration. Okay, in all cases. RO, the setup is different. I will show you the setup for RO. Okay, the setup is different.
So in this case, when it goes to the second filter after this, the retentate flow, so there the concentration level of the particles will be higher. So there the porous membrane parameters are different, or it is the similar?
It is similar. It is similar. The same. If it is ultrafiltration, similar membrane are being used in all modules. Okay, but gradually it will be denser and denser. Okay, challenges will be more. Now if you see, there are two philosophies. One is that inside feed. Okay, here if you see the hollow fiber, here if you see, this is the hollow fiber. Okay, and this is the hollow fiber. In the hollow fiber you are having the semi-impermeable membrane. Okay, so basically it is flowing inside. Okay, and the picture I have shown you, it will work in the same philosophy. Okay, and in the other case, the feed will be from a outer side. Okay, feed will be from a outer side. Both are having their own advantage, disadvantage. Okay, inner feed, if there is a contaminant level is less, inside feed is better. If the contaminant level is more, outside feed is better. But outside feed, because you are getting the larger surface area, flow dynamics will be better, but the damage to the hollow fiber will be higher in the case of outside feed. Now you can see several membrane arrangement. So one is the hollow, tubular, this is a solid material, okay, plate and frame, okay, and spiral wound. So this spiral wound I will show you in the case of RO filter. This is specially designed for the RO filter. Okay, so it depends on the structure, how it is made. Now I will show you that how the ultrafiltration works in the situation of outside to inside filtration.
Components include lower and upper cap, clamp, housing, raw water distribution channel and separator, pipe, hollow fiber. The raw water distribution channel and separators are situated in the middle of the filter. This specially designed inner distribution mechanism ensures that water is equally distributed in the module. For modified PVDF, ensures a high chemical and mechanical resistance to the hollow fiber. The hollow fiber has smaller pores on its outer surface, creating the active filtration surface. This design gives the membrane a high capacity of contaminants retention. The hollow fiber is both highly permeable and easy to clean. Modified PVDF has a higher mechanical and chemical resistance compared to other materials. The nanoscale pores located on the outer surface of the hollow fibers allows the water to pass through the thickness and retain the viruses, bacteria, and solids larger than 30 nanometers. These substances cannot enter the fiber, they stay outside. The pore diameter of our hollow fiber is smaller than 0.03 microns. The filtration process takes place from the outside towards the inside of the hollow fiber, so the membrane can be used for highly contaminated water, has a larger surface area, and can be cleaned more easily. During the filtration stage, raw water enters into the module. Raw water stays out of the fibers. Filtered water flows along the lumen of the hollow fiber and goes to the module outlet. The polyurethane-based coating holds the fibers and provides the tightness to the module. The clean and raw water never mixes through the module. When the filter is blocked, contaminants accumulating on the outer surface of the fiber are removed from the filter.
This is the retentant.
During backwashing, the filtered clean water is
This is the backwashing.
through the clean water inlet. As clean water comes out of the fibers, contaminants which have been accumulated on the fiber surface are pushed and removed. Concentrated sludge is discharged through the outlet. Backwashing is performed more quickly and effectively when combined with air scouring. When the removal of contaminants is not sufficient with backwashing and air scouring, chemically enhanced backwash and clean in place are applied. Our PVDF hollow fibers are extremely resistant to chemicals.
So if it is not possible by water, we can use the chemical or biological filtration. Backwash is also possible using enzyme. So there are ways to clean the filter media. This is another example for inside to outside filtration. So it is passing through the center of the hollow fiber, okay, and in centrally you are having the tube through which you are getting the permeate. Permeate means the clean water. You are getting the permeate. This is the hollow fiber through which the contaminant water is flowing, and then we can go. This is another backwashing technique. So for backwashing, the flow must be reversed. Using chemicals, okay. Yes, you can use water. If it is not possible through water, then chemical. Yeah, but depending on the chemical has to be selected. Again, after applying chemical, you will have to use the water also at the final stage. Now here if you see, it is best for inside to outside is best for low turbidity. Okay, for outside to inside is best for high turbidity. Okay, I am not showing all the, because these slides will be with you. You will get some idea. Risk of fiber breakage will be higher, lower in this case. That is the good point. So certain cases the inside to outside is better. In certain cases for high turbidity, the outside to inside filtration will be better. Okay, so if you see normal cases, mechanism based on the flow direction, thickness of the deposit increases, specific output to the filtrate material will decrease with time, because gradually the cake is building up, so filtrate will be less with time. But in the case of cross flow filtration, output to filtrate will remain the same after certain point of time. Thickness of deposit will remain the same after certain point of time, because it is not like the cake will build up just like this. So cake will never build up. So after a certain period of time, thickness will remain the same, specific output or filtrate will remain the same. Okay, this is. Now if you see the depth and membrane filtration, you can have complete blocking, because the blocking is the main concern in membrane. Complete blocking is possible, standard blocking is possible, cake filtration is there, intermediate blocking is there. So blocking obviously reduce the life of the media function, it can affect the function of the media. Now as I said that biological cleaning is possible for the cleaning strategies, backwashing. Physical cleaning is possible. People mostly go for physical cleaning. Okay, and if it is not possible by physical cleaning, then they go for chemical cleaning. Okay, it is not that always going for chemical cleaning, and biologically cleaning is also coming up. Okay, and you can use some enzyme for cleaning the membrane. So different membrane is having different pore size. If you see 10 to 0.1 micron, here ultra filtration 0.1 to 0.01 micron, nanofiltration 0.01 to 0.001, and RO it is further less. Okay. So at different stages we remove different kinds of material. For example, ions can be removed in the reverse osmosis. Small compound can be removed in the case of nanofiltration. Ultrafiltration can remove the virus and proteins. Microfiltration can remove E. coli, okay, and oil, micromolecules, colloids, suspended particles. Okay, so different filters is having different capability. Now going to the reverse osmosis, let us understand the mechanism of reverse osmosis also. And this is the cutoff of different liquid filtration technique. So depending on the cutoff, we will have to select that which kind of filter, membrane filter is applicable. Because this is the membrane filter, and the RO filter obviously need very high level of force. If you see the membrane filter, okay, ultra filter 0.5 to 10 bar, here if you see 7 to 75, energy requirement will be higher, much higher. So unless and until you require the RO, we should not go for RO because the energy consumption will be much higher. Okay, so that already I have discussed. You can have this slide because you can see the advantage of microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. Basically, you are removing everything. Okay, even the monovalent ions, okay, multivalent ions, these are also being removed in the case of reverse osmosis. That's why it is suggested that reverse osmosis water is not also good for health because we are removing everything. So this is the different types of membrane. You can have hydrophobic membrane, electrostatic interaction, adsorption. Different membrane manufacturer also coming up in a different types of membrane. Okay, biologically inspired membrane are being developed. So different kinds of membrane are also being developed. So sometime it could be electrostatic interaction, sometime it can give you the adsorption, hydrophobicity. Okay, so earlier membrane we talk about the size exclusion only. But nowadays the new membranes are also coming up through research, so that can give you some additional performance. And this is the interesting for reverse osmosis. If you see, several layers are being used. And feed channel pressure, this is very important. Here you are having the membrane. Okay, membrane is not only one polymeric material. That is, different polymeric material is there in membrane. Okay, 3 different polymeric material is there in the membrane. I will show you. And this is the feed channel pressure through which the permeate can pass through. So sorry, not the permeate, that contaminant water, concentrate. The concentrate will be able to pass through the feed channel pressure. I will show you that how it works. But this is the only the theory of reverse osmosis. Next slide I will show you how it works.
To all salts and inorganic molecules, as well as organic molecules. It is therefore a highly effective process for removing a variety of contaminants. Compared to traditional filtration technologies that rely on a screen or filter to remove particles, reverse osmosis is a pressure-driven separation process that employs a semi-permeable membrane and the principles of cross-flow filtration. Filtech RO membranes are composed of a thin film composite membrane consisting of 3 layers: a polyester support layer.
You see, it is not a singular component. Polysulfone substrate and ultra thin membrane layer.
Coated by a proprietary fouling resistance layer.
This is the speed pressure through which the water can flow.
This thin film composite RO membrane is packed in a spiral wound configuration that follows the principles of cross-flow filtration, where the flow is applied tangentially across the membrane surface. As heat flows across the membrane surface, filtrate passes through.
So it is basically moving in a spiral direction and it is moving to the center.
Filtech's membranes offer a special interlocking capability called IRA, which is an interlocking end cap technology offered to selected Filtech.
See, one module is attached to the another module. Okay. So up till this, the thing is okay. Got the idea? So in this case, basically the water moves, contaminated water moves in a spirally, okay, and gradually it moves inward because it is made in such a fashion. So gradually the contaminated water will move inside, and inside you are having the tube perforated tube through which you will get the permeate. Okay. And contaminated water will pass through the spacer, because in between that membrane you are having the spacer. Spacer, if you see, you can get several video in the YouTube also how the spacer operate. Okay. But again you give certain restriction so that it can the water has to pass through the membrane, because that is the basic philosophy. You will have to put certain restriction, certain resistance, so that water has to pass through the membrane. That is the basic idea. That's why the pressure differential is so high in RO. Now coming to the centrifuge system, there are two kinds of centrifuge system. One is that perforated basket centrifuge, okay, and this is the commonly used. I will directly go to the pusher centrifuge because of time less. Only the 5 minutes I try to cover. Pusher centrifuge, I will show the video, because inside the pusher centrifuge there will be metallic body, perforated metallic body, over which you can have the textile fabric. Okay, and this can be used in the case of pharmaceuticals and suppose expensive minerals recovery. So there we can use the pusher centrifuge, because it will be relatively much expensive. It is short, but maintenance cost will be also important. You can see how it operates. Cake is formed, but cake will be pushed time to time. Cake is formed and there is a pusher which is pushing the cake in a particular manner. You see, once it is coming to the edge, it is taken out. Cake will be taken out. So it will be pushed. Once the cake is formed, it is pushed. Again formed, it is pushed. So it is gradually pushing the cake, so that at the end, whenever it is coming to the edge, it will be taken out. You can see at the edge it is taken out. So abrasion is very important, because sometimes we neglect, we always think that efficiency is important. Abrasion also damages the fabric. So here you can have abrasion of the material with the particulate matter or with the solid matter. So abrasion is very important. Another is the pillar centrifuge. I will show you direct video, then the things will be clear. So it is basically slurry feeding. Initially it will be slurry feeding. So slurry is being fed. So see, slurry is fed, okay, and by means of centrifugal force you are you are extracting the water from the slurry. So here cake is washed. Filter cake washing. So dry spinning. Cake peeling and discharge. Although the same system is, I am showing one system to another, but whole system is embedded. Okay, so here it is basically you are peeling out. Cake peeling is there, and through the discharge mechanism you are removing the cake. So cake is peeled out, through the discharge mechanism it is been taken out, the cake is taken out. So which one is batch process, which one is continuous process, any idea? Out of these two, whether both are continuous process? Which one is continuous and which one is batch process, or both are continuous? Both are continuous, all agree?
Stopping the process.
No, not stopping, whether it is a batch or continuous, or it is only continuous or it is only batch. Second one is batch. First one is continuous, because you are for the washing and everything, you need another operation. During the operation, the filtration is not there. During washing and everything, filtration is not there. The first one is a continuous, because continuously you are pushing the material. Okay, so it is not a batch process. First one is a continuous. Second one is a batch process. This one is a batch process. Okay, it is not that you will have to stop for batch process. It is a batch process. But then, what is the advantage of this? The abrasion will be much lower, so it will act on the filter material, because filter material is also very costly. The life of the filter material will be better, because abrasion will be less in this case as compared to the previous case. So there must be some positive point. Remember that the batch process must have some positive point, otherwise why the people go for batch process? Always should go for continuous process. What the problem? Okay, batch process must have some advantage. So if you see, this is another setup for your blood filtration. Serum from blood is taken out. Okay, detection of biomarker. This is for cancer patient. Okay, we want to test the serum. Okay, there also tangential cross flow filtration is important, and this is a separate setup that has been shown that how it works. Okay, because see here it is uniqueness is that through centrifugal force, here you are having the filter media, you are pushing the solid particle one side, larger particulate matter in one side. So filter media can take out the serum from the blood. Okay, so direction of serum flow. So pores in oven and non-oven fabric. I think how much time I left? I think time is over, or okay. So this thing is important. So what I think that in my next tomorrow I am having lecture, first and the second, two lecture consecutive lecture I am having. So in two consecutive lecture I will discuss about the, because this concept is important about the pore size and how to voids and all these things. Okay, because I should not uh, make it in hurry, because the understanding of these pores and the particle size is very important. Okay, so this part I will discuss in my tomorrow's class. Okay, along with the cake, because there are also several things about the media. Okay, okay, then we can go for a tea. The tea is ready. Okay, okay, thank you all. Any question? So till now I have discussed all mechanism where you can make use of media filter. Okay, then about the media filter I will discuss tomorrow's class. Pores in the case of woven fabric is quite regular. Okay, this is a picture of a woven fabric, and this is a picture of a non-woven fabric, and the people conceive the pore size like this: closed pore, blind pore, open pore. This is the way the people conceive. Actual pore is not like this. Okay, because this is a multiple type pores will be multiple type, and they are all interconnected pores. If you see the non-woven pores, they are not very regular pores, non-woven pores, whereas the woven pores could be regular. Now, next to it, if you see, if you compare the pores of woven fabric and non-woven fabric, non-woven fabric pores will be broader, pore size distribution will be broader, but woven fabric pores will be narrower. If you see, it is sharp. So woven fabric pores will be narrower, okay, within a range, and the non-woven fabric pores will be very wider, because that also has some practical implication. For example, if you want to remove all 5 micron particle, so pores in the case of woven fabric, you can exactly remove 5 micron and above. But in non-woven, because the pore size will be large, small as well, so you cannot ensure that. That's why nominal rating is possible in the case of non-woven, whereas absolute rating is possible in the case of woven, because woven you can guarantee that 5 micron and above you can remove, because that's why you can make the pores in that particular fashion. Now You can see this is a oven structure, and if you see the dimension of this square, if this is the diameter, 1 by n1 will be the distance between one thread to the another thread. Okay, distance from one place to another thread. What is n1? Because textile person is, are more acquainted with this. Number of warp and weft yarn per millimeter. Basically, you are getting this size. Now, this size, okay, this dimension A0 and other dimension will be B0. If you take the root of it, you will get the equivalent port diameter. This is one of the way to estimate the port diameter. Whosoever in textile, they understand it, because basically it is the square geometry. You can also look it through microscope to get the idea about the pore size. Now, you can also use the harmonic mean instead of that geometric mean, and you can also take the area. Suppose if you are using image analyzer, you can take the area into account, and from the area you can find out the equivalent size of the pores. So there is a different way to estimate the equivalent size. Sometimes it could be harmonic mean, sometimes geometric mean, and area can be estimated through image analysis technique, and from that also equivalent you can find out D. But one point we must remember, whenever the structure is relatively open, in that case only you can use this. Otherwise, for closely constructed fabric, there will be overriding of the threads. Whenever I talk about the denim cloth, for example, okay, it is not that all the threads are lying in a single plane. The overriding of the threads are taking place. So if there is overriding of the threads, you cannot make use of this equation. So that is the one of the caution. So for jammed fabric construction, and if because of the compressibility also, you cannot make use of that. Now, pore size determination usually conducted by the following method of sieving method. So that is used for geotextile. Why we go for sieving technique for geotextile? Because the soil size will be much larger. Soil particle size will be much larger. That is under consideration. So therefore, sieving is very, it is used in civil engineering application. Optical technique can be used. Image analysis technique can be used. Mercury intrusion technique. It is civil engineering, it is extensively used. Although the people are using the image intrusion technique in textile, but it is not at all valid because of number of reasons. Because you cut the sample in a small size and the mercury can intrude from on all sides. It is not that because the flow direction is the perpendicular to the plane of the fabric, you must have the pore concept of pore in the perpendicular direction of the fabric, not from all direction. But mercury intrusion method basically provide you the pore dimension when the mercury intrudes from all direction. That is number one problem. Another problem is that when the mercury intrude inside the pore, it get compressed. The material get compressed, so whole pore dimension will change. That is why the initial time, but it is extremely successful in the case of civil engineering application, because civil engineering, it is very concrete. Okay, in a concrete structure, this is very much useful, because if the pore size is greater, obviously concrete strength will be less. So this is very much in use in the civil engineering application, but it is not so useful in the case of textile. So in textile, most relevant testing is the critical bubble pressure. Okay, but as I told you, because the pore may not define the filtration in number of cases. If the concentration of the particle is very less, in that case obviously the fabric or the membrane act like a screen. Okay, uh, it can separate the larger particulate matter, but pore and particles are not connected straight away in number of cases. Okay, for example, if you go for ultrafiltration, reverse osmosis, okay, in that case obviously the membrane size has to be smaller than that of size of particulate or size of the solid particle. Okay, there it makes sense. In certain cases it makes sense, but it is not that in all cases we can define the filtration capability based on the pore size and particle size. That also I discussed in my last class. So that is the problem with the critical bubble pressure technique, and airflow technique is also there. Now, if you see the relevance of pore size, porosities we can define, we can find out mean pore size, largest pores, pore size distribution, pore volume, through pore structure, gas permeability, surface area means surface area of the pore inside the pores. But we should not use it blindly, because many machine manufacturer obviously or instrument manufacturer will be pushing their material, pushing their instrument for measurement of the pores, and they will define the utility of the pores as well. But as a scientist, as an engineer, we must think the practical utility of this, whether that really makes sense by using it, not to use it straight away for certain application. So that is the idea, because in actual case pores are multidimensional and interconnected fibrous network. Estimation of pore size in case of non-woven is quite complex. So the scientists are evaluated it, they are giving the pore size, maximum pore, minimum pore or whatever, but as I told that we'll have to use our own judgment whether the instrument is giving us the right kind of data which can be used for engineering of the material. Why we need the pore size? So that we can engineer the material in accordance to particle size. That is the basic idea. Yes, what type of application we are using it. So that's why I am saying that blindly we should not accept anything, because many machine manufacturer or instrument manufacturer will be always pushing for the pore size analyzer. Now if you see over here, now the concept of voids, okay, porosity, there is another important formula I used to use for textile material, that is 1 minus m, it is the mass of the fabric, density of the fiber and also thickness. If you know the density, if you know the thickness, if you know the mass density, you will be able to know porosity of the material. That is the idea. Porosity, in fact, it is not an absolute parameter. That is again problem with the porosity. Many places I have seen the scientist or researcher take the porosity as an absolute parameter. Higher the porosity, higher will be the depth filtration, because last classes also I have told the depth filtration concept. So here it is not that porosity cannot give you the absolute voids. If you see the voids, total void, the equation is different. Although it is related to the pore size, in the next slide if you see, this is the calculation part. You can also go through the slide to get the calculation part. Here if you see the voids per gram, obviously it is in pore size, porosity is important while you are looking at the voids, but it is also impacted by the rho F. Okay, and if you see the voids per centimeter square of fabric, per centimeter square, that I have derived on my own, okay, because that is not given in the literature, that I have derived on my own. That is the reason that why I have derived per centimeter square of the fabric. Okay, we can have the voids, okay, and which is related to the mass density of the fabric also. So it is related to porosity, it is related to the mass density and also related to the fiber density. So per centimeter square you can estimate the void. Now what is the practical significance of the voids? Practical significance of the voids is the importance of depth loaded filter. So how much dot particle can be arrested by the media? More the voids, greater will be the amount of dot particle which can be arrested by the media. Okay, it is not the porosity. Porosity cannot define it clearly, because porosity is intrinsic property, whereas the voids is the absolute property. Okay, absolute behavior of the fabrics. Okay, the problem with porosity is still there. If you see the porosity, there is a problem. Why I say? Because this you will not get from any textbook or any journals, because there are some inherent problem with this particular parameter. What is the problem? For example, if you take porosity 1 minus m rho into T. Now tell me, if you are making the yarn very compact, okay, then what will be the fabric thickness? Suppose everything is same, GSM, count, everything is same, yarn is same. In one case you are using more twisted yarn. Okay, if you are using more twisted yarn, then what will happen to the T? No, only tell about what will be the thickness. Thickness will reduce. Okay, now mass of the fabric is same, the fiber material is same, thickness is reduced. Okay, then what will be its impact on porosity?
So overall intrinsic size.
No. Okay, just I am just coming to that. First, let me know if you are reducing the T by making the yarn finer, high twist, making the yarn finer. If you make it thin, then obviously this parameter will be higher and the porosity will be lower. On the other hand, you just imagine if you get the high twisted yarn, the fabric will be more porous. It will allow more fluid flow. That is the problem. In number of cases I have seen the research paper where this sort of problem is there. People try to address their issues by means of porosity, but it is not fitting well. Okay, if you want to address the depth filtration, okay, voids, it should be by means of voids, not by means of porosity, because porosity is not the right terminology. That's why I have mentioned it's not effective indicator for understanding fluid flow in the woven or knitted fabrics. So it is not a proper equation. Okay, so if you see, this is the pore dimension and the pore throat analysis is possible. Now coming to the particle size. Different ways we conceive the particle size. As in the last class I mentioned, equivalent spherical body is the concept. Why equivalent spherical? Because sphere is the only object where you can define its dimension by means of diameter. Okay, that's why we go for equivalent sphere concept. Now here, maximum length, this is possible, minimum length, that is possible, sphere of same weight, it is possible, sphere of same volume. Mostly in the laser based technique, we will get this data, sphere of same volume, sphere of same area. This is possible whenever going for laser based technique for assessment of the particle size. Now question occurs that why it is we are not taking the actual value. Okay, now actual value will be very tedious. If you look at under the microscope, okay, the particle size again in a mass of particle, they are not all same, they are all different. Okay, that is number one. Another major problem that why you are not going for that technique, microscopic technique, one is that it is very tedious. Another major problem, what is that major problem? What is the major problem that we are resorting to? We are going for laser based technique, not the microscopic technique. One is the tedious, obviously, but that will be one time only, one or two times the people can go for a tedious job and they can have some assessment about the particle size. Okay, but what is the major problem? No. Projection, okay, so time to time you will get the different projection, but the point here I am trying to ask that why the microscopic technique is a problem, why you are going for laser based technique, that is my question.
Actually, those particles would be there. We are using a forehand light. Very straight light, lightweight.
Because it is based on the two different techniques. Different techniques, laser based techniques are also available in different form. Light diffraction, okay, or time of transition. Okay, one of the major aspect that why we are going for laser based, it is the reproducibility. That is the reason that majority of the testing system have developed. Reproducibility is one of the major aspect for development of any testing apparatus. For example, if you see the yarn hairiness, that also we can get by apparatus, but whether it is absolute, it is not the absolute. That is based on the two-dimensional image we can get idea about the hairiness in the yarn. So it is not the absolute parameter. Why you are going for laser based? Primary reason is that is the most important reason, that reproducibility. If you are going for microscopic technique, person to person will be it will be different. Again in the same person also. Yes, observation technique. Same person also will get the different values. Okay, you will not get the same values always. That is the point. But we are going for this. But again, there is a problem whenever we are following to this. That's why I told in my last class, if you are having needle-like particle, spherical size will be small, but needle-like particle, the filtration capability will be more. If that is okay, if the particle shape is different, its filtration capability will be different. Filterability will be more in the case of needle-like particle as compared to equivalent spherical size. So there is a problem in defining the things, but we must know the background. We must have the fundamental clear. So what is the inherent lacuna in the system? Okay. Now that is why I define it particle shape and nature of particles. One is the whether it is close to spherical shape, okay, ultra sphericity means 0.9, or whether it is a rounded or not. So roundedness, there is a different equation, it is based on the two-dimensional image. Okay, it is based on the two-dimensional image, and sphericity is defined as the three-dimensional image. Okay, so in the case of laser based technique, obviously we assess this shape, okay, but particle shape will be different. We must have assessment of the particle shape for different application whenever I look at the filtration performance. Okay, so this is already defined. Sphericity is the surface area of the sphere of equivalent volume, surface area of the particle. Okay. Now again, it is not only particle shape and nature of particle, but hydroscopic nature of particle also govern the mechanism. Free flowing versus agglomerating nature of particle. Suppose the particle are getting agglomerated, so it become bigger. So bigger size particle will be easy to remove. There is a research team who work in the long time back in the coffee waste. So then trying to agglomerate the particles so that they become bigger, they can be separated. So this technique is used in number of places because this technique is very effective. Okay, so for example, in air filtration also the people going for injection of ammonia vapor so that the coal particle can agglomerate, they can form a bigger size, and bigger size particle are easy to remove. So these techniques are also prevalent whenever you want to remove the small size particle. Small size particle you can convert it in a bigger form, and if it is a bigger form it will be easier to remove. Now if you see, this is the, because very briefly I am covering it because each and every case there is a lot of things to say. Particle size measurement technique. If you see, there is a problem, as I said, scanning electron microscopy. Similar way the microscope is having problem. But one of the most prevalent technique is the dynamic light scattering for measurement of very small size particle. Dynamic light scattering is the option. Okay. Otherwise, you can go for laser light diffraction, but the laser light diffraction you cannot measure, because if you see among these, the most prevalent technique is that dynamic light scattering and the laser based technique. Okay. In the laser based technique, starting range will be 0.02 and somewhere like that. Whereas in the dynamic light scattering, you can measure very small size. 3 nanoscale particle also can be measured. But the issue is that whether it is required, for which application it is required, that has to be thought of. Because as you are going for dynamic light scattering, cost will be threefold, 4 times than the laser based techniques. So unnecessarily why we should go for this dynamic light scattering if it is not required. So this is all application based. Based on the application, we can choose which kind of technique will be more appropriate. Okay, because as I told you, it can go beyond 1 crore also if you look at the dynamic light scattering. Whereas that light diffraction technique, it can be hardly the 20 lakhs. Okay. Now pore shape and equivalent particle size concept. Okay. So pore shape will be also not very uniform. Okay. That is one another aspect, and particles are not also uniform. So there is no, as far as systematic research, where you can see the impact of both of these on the engineering of the material. Okay, engineering of the material, it is very important to look at the different shape, and according to that different shape of the pores and how to engineer of the pores. So there is no such study.
Shape of the pores can be determined from the microscope.
From the
Microscope.
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 Yes.
In that case, slice by slice cutting will be.
No. Okay, that is okay. But the point here is that pore size is not uniform. Again, you cannot well define that pore size in the case of non-oven. Particularly in the case of non-oven, it is more problematic. For example, if you are going for light projection from one side of the oven fabric, if you on the wall, you can find the lights. Okay, because through the pores the light can pass. In the case of non-oven, you will get the diffused light. You cannot get dotted light, okay, which is passing through the pores. Non-oven pores obviously will be different at different levels. But the point here is that it is not well defined. Okay, people are using it to certain extent in the research, modeling and all these things. But if you see the practical uses are very limited. Okay, practical uses means one must be able to design their material based on the particle size, based on the how the different pore size construction can be governed by different parameters. For example, if it is a needle punching technique, different parameter also can govern the pore size and the distribution. Now, factor affecting the particle retention and filtration efficiency. Last class he also discussed it. Properties of the solid is important, particle size, particle shape, particle charge, that is also very important, cake characteristics. Okay, so here I am not included everything because particle charge is also is influencing, because if whether it is agglomerating type of particles or not, that also can have influence on the separation. Properties of the fluid, liquid, density, viscosity, chemical nature, temperature and pH. Operating parameter, differential, pressure differential, operating pressure, pre-coat, okay, rate of filtration normally decreases with time. But it is not that you should not connect it like this horizontally, because these are the parameter under each heading. Okay, these are the parameter, these are the independent parameter under each heading. Don't try to connect it this way, okay, horizontally. Configuration of the media, media construction, surface area, blinding, clogging, special finish. Principle of filtration, vacuum, pressure, centrifugal, dead end filtration. That is how the different factor can influence. Now this is one of the important slide. If you see, we have still discussed about the different types of mechanism. In fact, the liquid filtration is more versatile. Okay, very complex machines are available, unlike the air filtration application. Okay, air filtration you can have HVAC filter, okay, industrial filter, okay, face mask. So limited. If you see automotive filter, limited construction. But in the case of liquid filtration application, there is a huge. It is endless application, and there are many application you can find different kinds of filters are being used. Different philosophy are being used. Now, if you see tendency of clogging of filter media, because that is very important. Filtration using gas pressure, then clogging will be more as compared to gas pressure. Filtration using centrifugal force, because clogging more means life will be less. That also I have shown you through the video. Filtration using a mechanical pressurizing system, that also I have shown you. Under mechanical pressurization also you can go for filtration. And vacuum filtration, the tendency of clogging will be more, as because particularly during the washing, because in vacuum filtration if you see the whole cycle, washing is done at the top of the drum. Now why the washing is done? Because it is not, the washing is not being done in all cases, particularly for mineral recovery. Okay, you are going for washing so that you can get the better mineral will be free from all sort of contaminants, other type of contaminants. Okay, so if you are going for water, for cleaning the cake, obviously whenever your vacuum is active, it can also take the water. Okay, it will also take the water along with the particulate matter. So tendency of the blinding will be more in the case of vacuum filter. So this is important while you are choosing the particular kind of system. Handling the higher sludge concentration, filtration using membrane filter, very low sludge concentration. Okay, very low sludge concentration, then only we can go for membrane filter. Then if it is more, then vacuum filter. If it is further more, in that case we can go for centrifugal force. And if it is very large, very high, in that case we will have to go for mechanical pressurization system. That also I have discussed. So you will have to see the sludge content, concentration of the particulate matter in the sludge, separation of fine particle in the sludge. Okay, so fine particle vacuum filter is not so effective, as compared to that filtration using centrifugal force will be better, as compared to the mechanical pressurization will be better than centrifugal force. Okay, then membrane using membrane you can, like RO, okay, you can separate out 0.0001 size of particles. So it matters a lot. Means which type of system you want to adopt. So that depends on the life of the media. So what is the sludge concentration, to what fineness level we want to work. Okay, but this came later on. Filtration using centrifugal force. If you see, it is a closed chamber. Okay, and it is expensive also as compared to other. So in pharmaceutical industry they are having great use of it, because in many other system it is done in open air. Filtration is done in open air. For mineral it is okay, but in pharmaceutical and certain activity you need it must be performed in a closed container. So the centrifugal force is very effective in certain application. Expensive mineral also you can use centrifugal force for separation, but it can be done in a closed container. So outside impact will be very less. Now if you look at the overall performance of the media, we talk about the maximum clarity, because terminology is little different whenever we talk about the air filtration and water filtration or liquid filtration. Maximum clarity means what? Maximum clarity, what is the equivalent term? Other equivalent term? No, maximum clarity means what? Clarity means clear. So what is the relevant other term? Equivalent term, I am asking. What is the equivalent term? No, effectiveness. Equivalent term. Filtration efficiency. Efficiency, are you getting? Other equivalent term will be filtration efficiency. More the efficiency, better will be the clarity. Okay. Now if you go to the maximum throughput, what will be the other equivalent term or relevant term for air filtration? Output is more. So what could be the, yes, pressure drop. If the pressure drop is less, then that means it can also lead to higher throughput. So that could be the indicator. Whenever you get the less pressure drop, that means you will get the higher throughput in actual situation. So this is the connecting terminology. Okay, low cake moisture content, this is also required, because we also want that cake should be disposed of in a dried state. That's why the people go for the drying also. Additional drying mechanism also incorporated to make it dry so that it can be disposed of properly. So certain ETP plant also, they dispose the cake in a dried form, because you cannot carry the cake in truck or trolley if it is wet condition. It cannot be carried from one place to the another place. So dried cake is always better.
Consider under hazardous waste.
Yes, this is the hazardous waste, and one of the major problem in India, number of cases, if you are dumping in a place, that should be made properly. So uses of geomembrane, uses of geotextile should be there to make the dumping site proper. Otherwise what will happen, if you are dumping it at certain places, okay, whenever there will be raining, so rainwater will be piping through and the groundwater get contaminated. So the proper lining is required. Okay, so there also the role of textile is vital. Okay, because so that your groundwater would be better. Resistance to blinding, that is important for life of the material. Okay, but the pressure also indicate this one also. If the blinding tendency is more, pressure will also go up. Okay, so pressure can give you both the idea throughput is higher or not. Okay, pressure also can give you the idea about the resistance to blinding.
Blinding is
Clogging. And next is the ease of cake release. Ease of cake release will be better. If you see, last class also I have shown you, this side is the cake side. Okay, it is made in such a way so that this side is predominantly monofilament, multifilament, and this side is span yarn. Span yarn. Like the denim cloth, if you see, it is made by two threads, but the blue color is on the surface. It is possible because of the weave structure. Weave structure, you can make the weave structure such that we can get the filament on this side, majorly filament, and back side it is span yarn. Span yarn is good for filtration. Okay, but the filament yarn is good for cake disposal. But if you are using the span yarn side, this one cake side, then what will happen? The cake will try to anchor over the surface. Disposal will be difficult. No, not particular clogging will be one aspect, but there is a projected fiber from the span yarn. Projected fiber will try to anchor the cake. Okay, so disposal of the cake will be a problem. This side is more smooth. That's why in normal cases also the people go for singeing. Singeing at one side. Why singeing? Because the protruded fiber must be removed. If you remove the protruded fiber, obviously the disposal will be better. Okay, so cake disposal is also very important. Abrasion resistance and other related to durability. Abrasion resistance is one of the very vital, because the viscosity of liquid is higher. Abrasion will be very high. Drum filter, if you see their mechanism, continuously it is abraded. Although the people have tried to change the geometry so that abrasion can be limited, but there is a lot of abrasion in the process. There will be also possibility of flex fatigue, because material will be deformed repeatedly. Under the repeated deformation, the problem will be more in the case of non-woven fabric as compared to woven fabric, because woven fabric, whatever way you make the non-woven, but it is more stable, but non-woven is having some unique property. That's why in a application, if you are using non-woven, non-woven will be cheaper than woven fabric, but it will perform better, but its life will be less. So both ways you will have to see the matter.
I had a query regarding it. Among the three, which is more suitable, whether plain or satin for acrylic? Among the three basic needs, which type of a fabric more suitable?
That I will discuss. Okay. So suppose if you are going for satin weave, that is better. So that is already there in the next lecture. Okay, different. I will show you the different configuration of cake. Configuration of fabric, that will be discussed. So this is all, because this is the remaining slide I could not cover in my last class. Okay. So now I am discussing about the. I think should we have a break? Then we'll start, or what?